Hello, in this objective we're going to be solving systems of equations by the elimination method. So our previous video we did it by the substitution method. This one here is a new technique. Okay, so let's begin by looking at some of the rules to obtaining equivalent systems of equations. Now when you're dealing with two equations with two variables, you can interchange any two equations of the system. That means you can make the first equation the second equation, you can make the second equation first, you can flip-flop the equations. Okay, it doesn't matter which one goes first, in other words. The second rule is you can multiply or divide the equation by any non-zero constant. So for example, if you have 2x plus 3y equals 4 and you want to multiply everything by 5 on that equation, you can do that. Okay, so you can multiply or divide each side of the equation by a non-zero constant, which basically means as long as it's not 0, we're good. Okay, so if you have 2x plus 3y equals 4 and you want to multiply by 5, then it becomes 10x plus 15y equals 20. And you're like, well, why would you want to do that? Well, when you're doing the elimination method, okay, you're going to end up adding or subtracting the two equations. And when you want to add and subtract the equations is when you want to eliminate one of the variables. That's how it gets its name, the elimination method. So if you multiply the two equations by a number that you choose to make one of those two terms the same, if you subtract them out, they would be eliminated. And then you could solve for the resulting equation. And that leads us to our third rule. You can replace any equation in the system by the sum or the difference of the equation and a non-zero multiple of the equation in that system. So basically what they're saying is if you want to add two equations in the system and put that as a result back into it, that's the biggest one right there. That's pretty cool because you can add or subtract two equations and then replace either equation that you have with that equation. Okay, and you can do that. So if you have equation 1 and equation 2, and you add those equations up and get equation 3. If you want to scratch out equation 2 and replace it with equation 3, you can do it. Okay, that's what rule 3 is saying. Alrighty, so let's look at an example. Alright, so how to solve a system of linear equations by the elimination. So we have 2x plus 3y equals 1, and we have negative x plus y equals negative 3. Now, if we were doing this by the substitution technique, what you would say, well, let's solve for one of the variables. Probably I would solve for the y in the second equation because it's the one that has a coefficient of 1. So all I would have to do is add the x to the other side. The problem is the instructions are telling me to do this by the elimination method. So we're going to follow this technique. You're like, well, how do we do that? Well, what you're going to do is decide on which variable you want to eliminate. Okay? So it looks like to me they are deciding to eliminate the x's. Okay? So what they're going to do is you're going to take that first equation and leave it alone, 2x plus 3y equals 1. But you're going to take the second equation. You remember you can multiply the equation by any number you want. And they have decided to multiply it by negative 2. Or actually just 2. So if you multiply it by 2, it becomes negative 2x plus 2y equals negative 6. So they took the second equation and multiplied by 2 and got that. So they replaced the second equation with the negative 2x plus 2y equals negative 6. That's what they did. Remember what you can do. You can take an equation, multiply by a non-zero constant, which is 2 is definitely non-zero, and then replace that equation with the new one. Okay? So yeah, why did they do that? Well, if you look at these two equations at the very end, the 2x and the negative 2x, if you combined those two equations, the x's are gone. What you have left is an equation that only involves y. So let's look at that. So if you add those equations up, you get the negative 2x and 2x. They're gone. You have the 2y, the 3y. Yeah, you have the 3y and the 2y, and that is 5y. And then if you combine 1 with negative 6, you get negative 5. So look what you get. You get 5y equals negative 5. That's chapter 1, section 1 again. Okay, so that's just solving a linear equation. So 5y equals negative 5 divided by 5 y becomes negative 1. Okay, so that's the trick. This is why it's called the elimination method. Yeah, well, what if you decided to get rid of the y's at the original instead of the x's? Well, you wouldn't have multiplied by 2. Do you think, what would you have multiplied by? Well, the top equation has a 3y, and the bottom equation has a positive y. So what if I had to multiply the equation times negative 3? Because then negative 3 times that y would be negative 3y, and then when I add those equations up, the y's would have been eliminated. You know, how do you know which one to do? It doesn't matter. Okay? It doesn't matter which one you choose. You just got to pick one. Okay? I usually pick one if what I would do is if I see two terms that have opposite signs, like one's plus, one's minus x, then I would have picked the x's like they did. Okay? But if they're both positive or they're both negative, then I normally don't pick it because my multiplier would have to be a negative number to make it back to a positive, because you want to change the signs of the two terms. So when you add them, they cancel out. So you want to have different signs. So if the signs are already different, like the x's are here, by multiplying by just a regular number like 2, then the signs are still opposite, and all you have to do is add them up. So this way you don't have to worry about subtraction. You can just remember just to add the terms up if you can remember that. Okay, so you get y, and you put the y equals negative 1 back in to one. You're like, well, which equation? Doesn't matter. You have to pick one, and then when you do it, I believe they say x is 2. Yeah, x is 2. All right, so you solve that equation, and you get x equals 2 when y was negative 1. So you just plug that in and solve for the x. Again, chapter 1 again. All righty. So if you look at that, okay, you can check your answer if you like. Like I said a while ago, you don't have to check them. If you want to check them, that's great. I wouldn't check them until at the very end of the exam, though. But yeah, you might want to. I mean, the only way you're going to miss this, guys, if you make a calculation error. Okay, so if y is negative 1 and x is 2, the ordered pair. Now, this is important. You have to write the solutions as ordered pairs. So the solution is the ordered pair 2, negative 1. So 2, negative 1, right 2, down 1, you're in the fourth quadrant. So these are two lines that's going to intersect at the ordered pair 2, negative 1. Okay, so that's kind of where they cross. Now understand, I've said this in the previous objective video, but where they cross is a solution to both equations. That's why it's called solving a system of equations. Because what you're doing is you're finding the ordered pair that solves both equations. So when you have that, you got these two lines, the common ordered pair is going to be where the point of intersection is going to be located. Okay? So what you're doing here is you're finding that ordered pair without actually doing the graph. Alrighty? So all right, let's move up the level of difficulty just a little bit, okay? So let's look at an application, all righty? So a movie theater sells, all righty? A movie theater sells tickets for $8 each, with seniors receiving a discount of $2. One evening, the theater sold 525 tickets and took in $3,580 in revenue. How many of each type of ticket were sold? All right, so let's look at that. So if X represents the number of tickets sold at $8, and Y let the number of tickets sold to the discounted price of $6. Remember, the seniors get a $2 discount, so their tickets are going to be $6. Okay, then this becomes the systems of equations. Okay, so we get 8x plus 6y equals 3,580. Now, what that equation represents is the revenue. Because if there were X regular price tickets at $8, there'd be the revenue made from that is 8x. $8 per ticket, $8 per ticket. X was the number of sold, because we don't know what it is. Now, the seniors come in, okay, they only pay $6 for their tickets, but we don't know how many of those seniors are at the theater either. So it's 6y is their revenue. So if you add the regular price to the senior price, 8x plus 6y is the total revenue. So that gives you $3,580. Now look at the second equation. X plus Y equals 525. Where does that come from? Yeah, it's 525 tickets were the total tickets that were sold. So X was the number of tickets sold at the regular price. Y was the number of tickets sold at the discounted price, the senior price. You add those up, is the total number of people that were in the theater that evening, and it was 525. So as you can tell, we can create a systems of equations using applications. So this is the two systems. So you solve them by a technique that we just talked about. Graphing, not so much. I wouldn't go there. Graphing 8x plus 6y equals 3,580. Probably not a good idea. Okay, it would be very, very ugly graph. And figuring out where that point of intersection is going to be is probably not likely. Okay, so let's go ahead and keep going here. So we're going to use the elimination method. That's the method of choice. Like, well, how do I know which one to use? It's your choice here, guys. If it didn't say how to solve it, you can go the elimination method or the substitution method. Personally, I probably would have used the elimination method as well, but you got an x plus y equals 525. To solve that, you could do it by substitution, by solving for x and get x equals 525 minus y. You could do that. And then substitute that in. But the reason I probably wouldn't want to do that because I'm going to be dealing with some huge numbers, which with a calculator is not a big deal. Okay, if you have a calculator in front of you, dealing with big numbers is not a problem. Okay, but I don't use a calculator that often, and so I do numbers in my head, and so that's probably why I would have chose the elimination method, because it would be a little easier on my brain. So 8x plus 6y equals 3,580. That's the first equation. And then they take the second equation and then they multiply by negative 6x. You know, negative 6. So they multiply by negative 6 is because they get negative 6x, negative 6y. And then if you multiply negative 6 times 525, you get that negative 3,150. Negative 3,150. And then you add those equations up. You'll get 8x and a negative 6x is 2x. And then if you add 3,580 to negative 3,100, I think, when I said 3,000 negative 3,150, you get 430. 2x equals 430. Okay? So if 2x equals 430, if you divide by 2, x is 215. Now remember what x was representing. X was representing the number of regular price tickets. Okay, so there's 215 regular priced patrons to this theater that evening. Now, how do you figure out how many seniors are at this one? Well, you need to take that number and do what with it? Well, you know x plus y equals 525. Then y would be 525 minus x, which we know x now to be 215. So there are 310 for y. So there are 215 undiscounted tickets, regular price tickets, and then there's 310 seniors coming that evening. So 310 senior discounts. So, but this is a very cool problem if you think about it, because you have to set up the system before you can solve the system. Okay? So, but usually, how do you know when it's a system and not? Well, usually when there are two unknowns in the same problem at the same time dealing with each other, there's two variables in the problem, so that's usually going to be a system. Okay? So it's a problem that's really worth understanding how to do. Okay? So that concludes this objective. Our next objective will be identifying inconsistent systems containing two variables. In other words, the systems of equations that when the lines are parallel. We're going to see what happens and how do you know that what's happening. Because it looks like in the substitution and the elimination techniques, it looks like we're solving for x and y and there was never an issue. Okay, here we got x equals 215. There wasn't an issue solving for x. But we're going to see in the next objective, there's an issue in trying to do that. Okay, so that concludes this video. If you have any questions on it, you let me know. And as always, you have a good day.